Mathematicians are lazy, but I want to just say something about, suppose that you have a question like this. Suppose I make a rule that if you have no absences prior to the first test, I will add 3 points to your test score. Given that you're awarded the 3 points, what grade will you receive for that first test? Well, think about that question. So you're going to get 3 points if you have no absences prior to that test. Well, what do you actually have to know in order to know your new test score? Well, there's a couple things you have to know. First thing is you have to know what your test score is. So what we want to show you is we're going to take your test score, we're going to add 3 points to it. Well, we don't like to write a whole lot of things, mathematicians, so we like to put variables in there. So we're going to use a T for test score. I'm going to make a T with a little line here instead of just making a T like that, because that'll look like a plus sign. So I stay away from those T's. Okay? And I have test score plus 3. Now let's talk about this. This T plus 3 is actually called an expression. Okay? An expression is just variables and numbers together with operational symbols. That's all it is. Okay, expressions do not have any comparison symbols, so there's no equals, there's no inequality symbols, nothing like that. This T is the variable, and that's really simple because it varies depending on your test score. Some people will have a T of 10. Well, I hope not 10. That would mean you got a 10 on your test. Some people might have a score of 85. That might be their T. This 3 is called the constant term. And it's constant because it never changes. The number is a constant because it never ever changes. That's why it's called a constant. So these are the parts of the expression. This one has this variable T and this constant 3. And this is just a rule. This T plus 3, this expression, and all expressions really are just a rule that tells us what to do. Okay? So let's take a look at how we evaluate this expression. Okay. To evaluate an expression. To evaluate an expression means to place a number in for the variable and to come out with some kind of answer. Remember, evaluate means to get a number answer. So let's suppose your test score was 86. So I know T is 86 plus 3. And this is really important. Whenever you substitute, you absolutely want to put what you're substituting in parentheses. It may not make a difference in this problem, but it will make a difference later when we learn some other sets of numbers. So 86 is your T score, and that's what goes in for T. I use a parentheses. And then 86 plus 3 is 89, and that's your new test score. So if you got an 86 on that test, never had an absence prior to that test, I'll add 3 points. You'll get an 89 for your new test score. We have just evaluated this expression when T was 86. Okay. I'm going to let you do some. So if you take a look at your workbook, would you fill in the chart? And then we'll come back and look at it together. Okay, so notice that the first one was done for you. Okay, and again, we use parentheses where we're going to substitute. So now let's do the rest, okay? Please don't forget this. You'll get the right answer even if you don't have this in here, the parentheses, but get really used to doing that, okay? So 81 plus 3 is 84. And then we take 69 plus 3, and we get 72. So these are your test scores if you got these grades and you were not absent, because you get to use this rule. And remember, the rule is just an expression. Okay. I think we use, if you think about it, we use expressions all the time. Let's suppose you need to put fencing around a square-shaped property that measures 20 feet on each side. I'm going to draw you the square, and we all know how good I am at drawing. So this may not go too well, but it's a square. All right, here we go. Okay. Remember, in a square, all the sides are equal? So that's 20 feet. Okay, you're putting fencing around this square property. So remember, fencing means we're going to have to go around this property. So I'm going to take a walk around. Well, notice that I really do know everything I need to know here, because I know that this side is 20, this side is 20, this side is also 20, and so is this side. So to get my perimeter, I'm going to add 20 plus 20 plus 20 plus 20, which is 80 feet. However, there is a shorter way to do this. Since all of these are the same side, instead of calling this 20, we can make a rule for any square we had, whether the side is 20 or 25 or 50. We can call this side S. And what we could do is say that our perimeter is 4 times the side. And this is for a square. This is square only. This works in a square because all the sides are the same. And instead of saying 4 times the side, remember how lazy mathematicians are. For a perimeter, we could just use a P. Then we can substitute the 4 times the side. Again, we don't need the dot. We don't need any symbol between here, because as long as they're attached with nothing in the middle, it means they're attached by multiplication. So here is the rule for the perimeter of a square. Okay, so we use these rules all the time, no matter what we do. Okay, let's take a look at this P equals 4S, or just particularly the 4S. And then we'll take a look at some other expressions. Okay, so if we have 4S, I want you to notice these little, the little parts of this expression. Okay, remember that these are attached by multiplication, so these are both factors. But more importantly, this 4 factor is called the coefficient. Coefficient is the number factor. Some people call it the numerical coefficient. This S is called the variable factor. So the coefficient is the number factor. Sometimes it's called the numerical coefficient, and the variable factor is obviously the variable. Let's take a look at some other expressions. Okay, so we have 1x, let's say. Let's talk about what that means. 2x, 3x, 4x, and etc. We can keep going if we want. Let's talk about what this means. 1x means 1 times x, or just x. 2x, remember this is multiplication. It means 2 times x, or 2 x's. This really means x plus x, because remember, repeated addition is multiplication. 3x are 3 x's, because remember, repeated addition is multiplication, and same for this. Oops. X plus x plus x plus x. So there's your 4x. Now let's take a closer look at this 1x, 2x, 3x, 4x. Okay? These are all expressions. Okay? Let's talk about the coefficient of each of these. Okay? So 1x, 2x, 3x, 4x again. Let's talk about their coefficient. Remember, the coefficient is the number factor, so the number is a 1 here. The number here is a 2. The number here is a 3. The number here is a 4. And the variable factor is the same for all of them. The variable factor is just x. So that's pretty much how easy it is. So remember, 1x is the same as x. That's really going to be important. Okay? 1x is the same as x. So if you don't see a number here, there is a number here. Even if you don't see it, it's a 1. Okay? All right. So let's take a look at this next chart that we want to substitute with. Okay, so take a second to do this chart, and then we'll come back and look at the answers together. Remember, when you substitute, remember to put your numbers in parentheses. Okay, let's see how you did. Remember, there's a couple of things we want to make sure we do. One thing is we want to make sure the numbers are put in parentheses. We want to make sure original parentheses stay on the problem, so you're going to be a little careful about that. You want to make sure you work down, and so if there's any work you have to do, you do it off to the side. And you want to make sure you keep everything nice and neat and you don't squish. Okay, so here we go. We have x plus y. That's kind of called the skeleton effect. Okay, I made that up, but it works. Okay, where you don't have the numbers in there yet, but you're just going to write down your parentheses. Now you'll stick the numbers in. So x is 3 and y is 4. Now, I know you think this is bizarre because the truth of it is that you don't really need to do that because you can get the answer without that. But later on when we do more sets of numbers, that's going to be important. I'm going to tell you what I'm going to do. I'm going to fix this chart up a little because I'm not going to have enough room here. So let me do that. Okay, because again, we want to work down, and I didn't leave enough room for me to work down. So that was my mistake. So let's fix this up. Tell you what, I'll do the problem and then put the rest of the numbers in as I go. So I don't squish, because that's the #1 rule. No squishing. That's a math term, squishing, I think. Well, don't look it up. You won't find it. Okay. So 3 plus 4 is 7. Okay, so your answer is 7. Here, this is x times y. Okay, so x is 3 and y is 4. So x times y is 3 times 4, or 12. So in this case, when x is 3 and y is 4, your answer is 12. Now be careful here. Here's what we're going to do here. We're going to actually write, I'm going to actually do this. Give me more space here. We're going to actually write the original parentheses on the problem. Whenever you have exponents, whenever you have an exponent, you want to put it outside, okay? And then we're going to put little parentheses inside, okay? If you want to use a different kind of parentheses, that would be fine too. And the y is 4, and the x is 3. Now watch what we're going to do. Never take off the parentheses until you do a multiplication step. So order of operation tells me to do what's inside. 4 minus 3 is 1. But I didn't do a multiplication step, so I did not take off the parentheses. Okay? So now this is 1 cubed. 1 cubed is 1 times 1 times 1, which is just 1. So that's how that looks. So that's when x is 3 and y is 4. Okay? Now we'll do the same for the other two problems. Actually, you know what I'll do? I'll finish that row because there's 2 more before I go to the other 2 numbers. So let me finish off that row. And for the next one, we have 3y squared. And I kind of wanted these two up together. And 3y quantities squared. Let's make sure we do these. These should give us different answers. Let's see why. Notice that your exponent, this will look like this, 3y squared exponent outside. Your exponent only works on what's to its immediate left. So think about the exponent falling down, and what will it fall on? Okay, it doesn't fall straight down. It falls a little to its left. But if it falls down, it'll fall on the y, so the y is the only thing being squared. Where here, if this exponent falls, it falls on the whole quantity, so actually the whole quantity is being squared. Let's see how that works out. Okay, so y is 4. So we do 4 squared, because remember, exponents before multiplication. 4 squared is 16, and then we do 3 times 16, which is 48. Now here, a little different. We're going to set it up with the original parentheses on the problem. Here's the 3. Here's a spot for y. Again, y is 4. So now we have to do what's inside the parentheses first, so that's right here. 3 times 4 is 12. We can take those off, okay? And that's squared. 12 squared means 12 times 12, and 12 times 12 is 144. Notice different answers. Look almost the same, but different answers, because here only the y is being squared. Here the product is being squared, so totally different answers. Okay? So let's see what happened if we do the same thing with 0 and 6. Okay. Okay, x plus y. 0 plus 6, which is 6, right? Just substituting in. That's kind of an easy one. The next one is x times y. Parentheses. So now we stick the x and the y in. X is 0, y is 6. 0 times 6 is 0. There's that 0 property rule. Anything times 0 is 0. Now, y minus x quantity cubed. Okay, so we need the original parentheses. All right, we're going to take y minus x, and the y is 6, and the x is 0. Got to do what's in parentheses first. 6 minus 0 is 6. 6 cubed is 6 times 6, which is 36, times 6 is 216. Probably have to do that off to the side. Okay, so let's finish off with 0 and 6. Let's do that 3y squared and 3y quantity squared. Okay, so 3y squared, and y is 6. And 6 squared is 36. And if you have to do this off to the side, do it off to the side. 36 times 3, that's 108. Okay, here, we're going to take the whole quantity. We're going to square it. So here's the 3, here's the y. Okay, got to do inside parentheses first. This is 18 quantity squared. Now we're going to square that. I think I'm going to do that off to the side for sure. There's a 6, 8. 1 times 8 is 8. 1 times 1 is 1. 324. Okay, so that takes care of the 0 and the 6. Now we have one more to go, the 2 and the 12. Wow, this is a long table. But hopefully by the end you'll know how to substitute. Okay. X, I should probably have this memorized right about now. X plus y. Oh, that's a bad slant. Let's try that again. Okay. X is 2. Y is 12. 2 plus 12 is 14. Some more easy than others, aren't they? Okay. XY. 2 times 12, 24. Y minus x cubed. Okay, y is 12, x is 2. That's 10 cubed, but powers of 10, we can do this. 10 times 10 is 100. 100 times 10 is 1,000. Okay, so 2 left, and we've finally completed this table. All right, 3y squared, my favorite too. And 3y quantity squared. Okay, 3. Y is 12. So this is 3 times 12 squared. 12 squared is 144. I'm seeing sidebar here. Here we go. 144 times 3. 432. Okay, last one. 3y quantity squared. Y is 12. Okay, 3 times 12 is 36. Oh yeah, I'm not doing that one in my head. 36 squared. $1,296. 1,296. Okay, so hopefully you understand how to substitute. Remember the parentheses. Remember if you have exponents, the exponents are outside. Remember that you want to keep all original parentheses on the problem. Okay, let's take a look at these two things, and let's talk about how they're different. Okay, we'll take a look at this one first, and you might notice that this one does not have an equal sign, but this one does. So let's talk about that. This has no equal sign. Has no inequality sign. Remember, the inequality signs are the is less than, is not, is less than or equal to, is not equal to, all of those. So it has none of those signs. Since it has none of those signs, this is called an expression. This has an equal sign. So it's called an equation. All an equation is an equation states that two expressions are equal. So 5x minus 3 is one expression, and 17 is the other. Okay, let's look at what you can do with expressions and equations. Okay, so let's come back here. And there are two things you can do in an expression or an equation. In an expression, you can either simplify or evaluate. Remember, evaluate means I'm going to get a number answer. Okay, so let me show you what I mean. Let me give you an expression like the following. X plus x plus x plus 4. Well, let me just stop at x plus x plus x. Okay, if I have x plus x plus x, that's an expression. I can add those. X plus x plus x, we showed you earlier that x plus x plus x, since it's repeated addition, is multiplication. So that's just 3x. If I have one x and another x and another x, I just have 3x. That's simplifying. I can do that. Okay, now I can evaluate. I can evaluate (3x) when x is 60. I don't have to pick 60. I can pick any number I wanted. Why did I pick 60? I really have no idea. Okay, so let's do that. 3x when x is 60. Well, I see my x. I put a parentheses. I put the 60 right there. And there's 180, which we've done already in that last set of examples. Okay, so this is evaluating, getting down to a number answer, and this is simplifying. You can actually give the direction here to simplify, and you would get the same answer, because simplifying means do whatever you need to do with the problem. Evaluate means get a number answer. So you cannot use the direction here to evaluate because there are no numbers to plug in to get a number answer. Okay? Now, in an equation is interesting because you may be able to simplify inside an equation, but the goal of an equation is to solve it. Okay? So you want to solve the equation. Okay, to solve an equation means to find a number that you can plug in for the variable so that it'll make a true statement when you're done. That's solving the equation. And whatever answer that is that makes it true, that is the solution to the equation. Okay, so let's take a closer look at that. Let's see, is 4 a solution to this equation? All right, so here's the problem. Is 4 a solution? You know what? That's going to be too squishy. No squishing. Remember that rule. First rule of thumb, no squishing. Leave lots of space. Most people make errors because they don't leave enough space. Okay, that's the question. Well, to find out if 4 is a solution to this, I have to plug 4 in where I see the variable. Well, there's only one variable, so I plug it in there. Write the problem. We're substituting, so we're going to use parentheses. Put that number inside the parentheses. 5 times 4 is 20. 20 minus 3 is 17. That is true. 17 equals 17. Generally, you go down to this step. I know you can see it here, but generally you should see that both of the sides are equal, and that's a true statement. So yes, 4 is a solution because it makes the statement true. So yes, and you have to say yes, because that's the question. Yes or no, is 4 a solution? Yes, 4 is a solution. Now you don't need to know this part, you don't need to write this part, but you need to know it. It's a solution because it makes the equation true. So that's how you determine if when you're given a number, if that's a solution to the equation. You just plug it in. If it's true, it's a solution. If it's not a solution. It's pretty simple. Let's try another one. Okay. Is 2 a solution to 4 times the quantity x plus 1 quantity squared equals to, better one, right? That's way more fun. It's better. Okay, so let's take a look. I'm going to give you a second to do this. in your workbook, and then we'll look at the answer together. Okay. All right, let's see how you did. We're going to plug in 2. Remember, we're going to do this. We don't really have anything to do on this side because it's just 24, but here's all our work. We got to plug 2 in here. Now we got to do what's inside the parentheses first. 2 plus 1 is 3 squared. 3 squared is 9. Oops. Don't need the squared anymore. I already squared it. 4 times 9 is 36. And 36 is not equal to, oh, wrong way. For all those people who always write things backwards, you're welcome. Okay, 36 is not equal to 24, so that's a false statement. So no, 2 is not a solution. No, 2 is not a solution because it does not make the equation true. Okay, that's it. All right, so now we get to play with words and put them in symbols and vice versa. So let's take a look at that. I hope it makes sense of how to tell if a given number is an answer to your equation. Okay. Okay, now we're going to take some of these words and plug in what we know. So it says evaluate the following using 20 as the number. Okay, so evaluate. This is in your workbook as the number. So wherever you see the number, you're putting 20 in. Okay, so let's start with number 1. 7 more than the number. Okay, well, this is all about keywords. 7 more than the number. So we have to figure out what more than means. Be really careful here. More than, is that going to be the inequality symbol? Think about that. I hope you're thinking, no, it's absolutely not going to be an equality symbol because even without my big is, there is no is there. So it's not the inequality symbol. So more than, if you remember from our keywords, means plus. So 7 more than the number, and the number we said was 20. So 7 plus 20 is 27. Okay, let's look at number 2. 8 subtracted from twice a number. Okay. A couple of keywords here. One keyword is subtracted from, or just from, if you want, because from means I'm going to subtract, but subtracted from is the whole key phrase here. And twice we didn't really talk about yet, I don't think. Twice means 2 times, okay, to double something. Okay, so 8 subtracted from twice a number. But here's what you have to remember. We did from yesterday, and twice a number, okay, comes after the word from. Whatever comes after the word from has to go first. So twice a number. Remember, the number is 20, and you're subtracting 8 from that. So that's the way that looks. 2 times 20 is 40. 40 minus 8 is 32. So the answer is 32. So be careful about this word from, and now you know what twice means. It means to multiply the number by 2. Okay, let's look at number 3. We want to talk a little bit about number 3 and the way you're going to see it most of the time. Okay, number 3, it says the product of a number and 20. And again, this is all in your workbook. Okay, a couple of keywords. Product. Now, here's the deal. We know what the number is already. The number is 20. Product means to multiply. Remember, and doesn't tell you to add. And just tells you where to put the operational symbol. The operational symbol is to multiply. So the product of a number and 20. And means to multiply, and 20. You can do it that way, or remember, you can use parentheses. It doesn't matter how you do it. Okay, but either way you do it, with parentheses or without parentheses, with the dot, it's still the same thing. 20 times 20 is 400. So that's the answer. However you want to write that is up to you. Remember, there's a lot of ways to do that. Number 4. Number 4 says the quotient, keyword, drum roll, oh sorry, of a number and 2, comma, that comma is important, we'll talk about that, increased by 5. We're going to talk about that comma and why that's important. Okay, quotient's a keyword. If you remember, quotient means to divide, but that's not where the division symbol goes. The division symbol goes where you see the and. So this is where the division symbol actually goes. Okay? That's where we have to put it. See that comma? That comma means that's not part of the quotient, because that means, okay, new thought coming. So here we go. The quotient of a number, so that goes on top. Remember, I'm going to do quotient like this. I'm not going to use that division symbol. I'm going to use the line. Okay. So the quotient of a number and, that's where this line goes. So the number and 2 increased by 5. How do I know that this 5 doesn't go here? It's because of this comma. This comma says, there's my break, okay? So I'm taking the quotient of whatever's on the left side of and whatever's on the right side of and until the comma comes, okay? So that's how I know I'm just dividing the 20 and the 2. So 20 divided by 2 is 10. 10 plus 5 is 15. All right, so that takes care of that. So that's a big one. The comma is important, quotient's important, but that and tells me where to put that division line. And I'm not going to use that division symbol that we used in elementary school. I'm going to use the line, okay, like almost a fraction line. All right, let's look at the next one. Number 5, 12 less than a number. All right. The key thing here is the whole entire phrase less than. Remember, less than means subtraction, but you have to switch the order. Whatever comes after it goes first. So 12 less than a number. So the number's got to go first, less than, okay? And here comes the 12. So 20 minus 12 is 8. So remember, the phrase less than or the word from has to switch the order. That's really, 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 really important. Okay, let's do 6. 12 is less than a number. Okay, I put this one here to trick you because it says evaluate, and evaluate means get your number answer, but truly I can't evaluate this one. Okay, so this is almost a trick. I hope I didn't catch you because I didn't put my big is up. But here's is less than, okay? That's the symbol, the inequality symbol. 12 is less than a number. The number is 20. We cannot evaluate here because there's nothing to evaluate. That's just an expression, okay? So that takes care of that. Now we're going to take the 20 out and make you do this when you don't know what the number is. So let's take a look at that. So make sure you keep reference of this page in your workbook as we do the next set. Well, now I can have any number. Let's call that any number x. You didn't have to call it x. You could call it whatever you want. Some people like to use their own initial of their name. I personally like x. X is my friend. Okay, so here we go. Same examples using an x. So let's try this. 7 more than a number. I'm going to give you a chance to do some of these. So if you would take a second to do that, then, and then we'll do them together. All right, let's see how you did. So all we did was take the 20 out and put in x as your number. So again, more than, no is, so it's not the inequality symbol. 7 more than a number. Now, again, we could write x plus 7. I would absolutely mark that correct. However, I think I would really rather stay with going word for word. This way, you only change the order with the word from and the phrase less than. But if you wrote x plus 7, that's definitely okay. All right, 8 subtracted from twice a number. So we have this subtracted from, and we have this twice. Remember, whatever comes after the word from goes first, so twice a number is 2x. Now, I know some of you are going to do this, 2x. Some of you are going to do this, 2x. Some of you are going to do this, 2x. It doesn't really matter. They're all correct. I call this like too much parentheses. You go in parentheses crazy. You don't need to go parentheses happy, okay? All the deal is that if I write 2x like that, it's neater, it's cleaner, and I know they're attached by multiplication because there's no symbol in the middle. So I prefer this, but these are not incorrect. I'd have to accept that. We don't want 2 little xx. We don't want that. That little x for a times has to come out, because in algebra, that would really hurt us. Well, it's really confusing. So I'm going to do twice a number, okay, and that was subtracting 8 from that. 8 subtracted from twice a number. So it looks like that. And again, you could even write x2, but that just looks funky, okay? Nobody really does that because generally, we talked about coefficients before, and coefficients generally are written in the front. 2 is the coefficient, x is the variable factor. You generally write the coefficient in the front. So it really does look like that, and that looks pretty neat and pretty nice, okay? And it's clean. It doesn't have all those parentheses going on. Which brings us to this one. The product of a number and 20. Product means to multiply, and is where the multiplication goes. The product of a number, if you go word for word, you're probably getting something like this. Or with your parentheses happy bit. And we don't want to do that. But again, the coefficient generally goes first. It just looks nicer. So most people don't write x20. Most people write 20x. So we're going to keep this 20x. Though if you write x20, I cannot mark it wrong. But that's really more well respected, that 20x, that coefficient in the front. Okay, so that's the first 3. See how you did on the next 3. Again, if you had all those other things going on, the parentheses, I can't mark it wrong. It's just not as neat and clean. But it's good. It's still good. The fact that you even got it all, we're halfway home, right? So that's all good. All right, let's look at number 4. The quotient, if I could spell, of a number and 2 increased by 5. Okay, the quotient, that means to divide. Okay, the and tells me where my division symbol is going to be. And 2 increased by 5, there's the comma, so we're not going to look at that increased by 5 yet. We're going to look at the quotient of a number. The number is x, and 2 increased by is our other key term or key phrase, increased by plus 5. So x over 2 plus 5. Okay? Number 5. Number 5 says 12 less than a number. Okay. Remember, this also is not an inequality sign because I don't have an is. 12 less than a number. Remember, whatever comes after the phrase less than goes first, so the number goes first, x minus 12. Really important that less than and from switches the order. Okay. Last but not least, number 6, 12 less than, is less than, sorry. 12 is less than a number. There's your is. Should be bigger than that because he's so important. But 12 is less than a number. And that's how that looks. Again, kind of fooled you because it says evaluate, and you cannot evaluate that because it's an expression that doesn't have a value for x. Okay? And that's it. That's how equations and expressions are different. And next time we meet, we're going to look at a whole new set of numbers.